Now after selecting the valve selection and valve construction, we'll go with a actuator selection. So as you know, actuator depends on the shutoff pressure. As we discussed earlier, this is a shutoff pressure, so we have inputted during the valve sizing. So based on that, it will size the actuator, this software. Before that, we have to select what is the type of actuator selection. So we will have a different options, but we are going with a spring and diaphragm type. And spring action fail mode. Or fail mode. So signal fails, what will happen? Should go to open condition, you have to select the open. Fail mode. So this is a fail mode. So as we discussed in the actuators, so when signal fails, or air fails, air supply fails, or pneumatic signal fails, so valve will go to the open position, that is a spring action. So it will go to open position, that is a safe position as per the process requirements. Open is a safe position. You can go with a lock-in last position also if that is a requirement. At the moment, safe position is open. So this is also another option, lock-in last position. Whatever position is there in the valve, 30%, 40%, it will hold at that position. So at the moment we will select that is not required. Hand wheel is required, yes, it is also required. Side mounted, normally we will take available air supply. Air supply in PSIG we will select because at minimum air supply also we should be able to operate the valve. We should be able to operate a sufficient force. That's why it is asking for available air supply minimum and maximum. Minimum may be 60 PSIG, maximum may be 100. So at 60 minimum we should be able to develop a full force on the diaphragm. So like this we have to select. So then we should go with a positioner. So as you know, we need most of the industrial valves will have a positioner to act against the process pressure acting on the plug of the valve, and also so there are frictional forces in the valve, so that the valve will open as per the desired controller output signal. So these positioners are important to drive the valve according to the command, input command that is coming from electro-pneumatic converter. So as per that command, this positioner tries to open the valve. So this is so we'll discuss this in the next lectures. So positioners also we have to select on the actuator. What is the type? Pneumatic will select. Manufacturer model, it is based on the Fisher only positioning input. The input is a 3 to 15 psi. This signal is coming from electro-pneumatic converter or I2P converter. Positioner action, it has to tell it is a direct. So direct means so normally valve is open, it will tries to close as signal increases. So you need gauges on it, yes, we need small gauges to indicate the air supply, input signal and output signal from the positioner. Hazardous area is not applicable. I2P transducer also, it is an integral part. What is a I2P transducer? This is electro-pneumatic converter. So what is output here? It is also 3 to 15 psi. So what is the input? 4 to 20, it convert into a 3 to 15 psi. So we should have air regulators also. That also we have to select. If you require booster, if Pneumatic lines or long lines, we need a booster also, that also we have to select. We have to put the tag numbers also. Like this, you have to select the positioner. And sometimes you need additional accessories that we'll see. That is a solenoid valve. As I told you, sometimes control valve will get a signal from the emergency shutdown system. So this solenoid is in the inlet to the diaphragm pneumatic signal. So this solenoid valve will close and forces the valve to go open to the fail-safe position. So this solenoid valve also you have to select. Manufacturer model or Fisher only. So what is a voltage? Normally it is a 24 volts DC. Normally it is a two-way. Material maybe stainless steel. We should add a tag as per the project requirement. Then we'll have a limit switches also. Limit switches is to indicate valve is full open or 50% open or full close. So limit switches also we have to specify. So this is a type, means we can have a mechanical type, that is a roller type. So this stem will operate this roller and gives a contact. Manufacturer model or belongs to the Fisher only. Contacts, how many contacts it has to give? Single pole, single throw. At the moment we will select a SPST. Actuation points, how many actuation points? One open, one close. Two actuation points. And it will have a current rating also and voltage rating also. If it is AC, you have to enter the frequency also. Current rating, or the rating should be able to have at least 1 ampere rating. Voltage may be 24 volts DC, normally we will use for contacts. So like this, we have to specify other components also of the actuator. So all these things will be going into the ISA sheet. So this is the control valve specification sheet. So all the process data as we entered in the sizing module. So all the process data is here. And the selected valve data is there. What is the opening? What is the trim parts? All these things are here. And the actuator type and all the details about the actuator is also selected here. So this will be final data, final document which goes to the vendor to select a suitable valve. So this is important. This completes the sizing of the valve and actuator. So this we can so this is all based on this installation data, valve sizing, valve selection, valve construction, actuator selection, positioner selection, and additional accessories for the actuator, and of course the characteristics of the valve. So based on all these things, your final ISA sheet will be developed. So you can save this in any other form, and you can put it, you can copy and send to the vendor.